Hey everybody, sorry, little audio issue. So this is a good example. This is how the notes are going to go. These are, unmute my audio. It keeps telling me I'm muted. Sorry, these should go better from here. All right, so this is a good example of how the notes are going to go. This is section 4.5. This is the beginning of this course for us. What's going to happen in here is we're going to walk through the notes. You are going to have a PDF copy of the notes before I've gone through them here in your section of Canvas for 4.5, and then you're also going to have a version of the notes with the work on them to go along with the video. Use whatever version of that works better for you. I find for me that it's easier to work along on a clean copy and do the problems along with, and then use the ones that are already finished just as references as you need them. So this is section 4.5. Everything in chapter 4 should be review generally for you. But I will tell you that this is the chapter, we don't do a ton of chapter 4, but this is the chapter on which basically everything else sits that we do in this course. So it is really well worth your time to really dig into this chapter and make sure you are comfortable with all the things we do in the next 3 or 4 sections. I think it's 4. So that you sit on a good base to do the next things. Okay. So in 4.5, we're going to talk about greatest common factors, negative factors, binomial factors, and factoring by grouping. I know this whole conversation probably gives you the shivers, but you're going to be okay. So the greatest common factor, when we talk about a greatest common factor for a polynomial, it's the greatest factor that you can divide evenly from each term. It's for real each term. You can't take a greatest common factor out of some things and not others. That's not how it works. Okay? All right. So when we're doing this, identify the greatest common factor that's going to work for everybody. It's like Christmas. You can't give a present to 2 kids in a family and not the third. If it doesn't work for everybody, you can't do it. Write each term as the product of the greatest common factor and whatever's left, and then use the distributive property basically backwards to pull it out. The thing to remember here is you can always check in algebra by redoing your work the opposite direction. If it works out and you get back what you started, you're good. And if you don't, something went wrong. It's easy to check yourself. So here, we're going to look at the greatest common factor. When you do this, take a look at numbers first. All right, so I have a 12 and a 30. The greatest common factor to 12 and 30 would be 6, right? I can divide 12 by 6, and I can divide 30 by 6. So I'm going to write down a 6. And then I have an x cubed and an x squared. Well, this one's x cubed is made out of 3 x's, x squared is made out of 2 of them. So the most I can take out is x squared. So that's what I'm going to remove from everybody. Now let's see what's left. Well, I took a 6 out of 12. 6 times 2 gives me 12, so 2's left. And I took 2 x's, x squared, out of x cubed. That means I have 1 left. And then, let's see, out of 30x squared, I took out 6. I divided out a 6. That leaves me with a 5. And I took away x squared. I divided that out. And really, x squared divided by x squared is just 1. That's nothing left. Then we can check ourselves. Remultiply. Okay, so 6 times 2 is 12. X squared times x is x cubed. 6 times 5 is 30. Oh, I need a plus sign. And x squared times whatever is there, the 1, is x squared. And we're back to where we started. All right, let's try the greatest common factor here. Again, just like before, check the numbers first, right? Let me go back to blue so we're not in yellow red. In this case, the 3 sort of dictates how this is going to work, right? So the most I can take out of everybody is a 3. So take out a 3. Now look at the c's. I have a c squared, a c cubed, and just 1 plain old c. So that's the most I'm going to be able to take out. And let's look at the d's. I have a d cubed, a d squared, and a regular d. So the most I'm going to be able to take out of there is a d. All right, so now let's do the numbers. 12 divided by 3 is 4. So I have a 4 left there. C squared divided by C is just 1 C left, so that's 2 C's. I took out 1, I have 1 left. And D cubed, I took 1 out, I have 2 left, D squared. All right, minus, let's see. Let's change a color. 30 divided by 3 is 10. C cubed, I have 3 of them, divided by just 1 C means I have 2 left. And then D squared divided by D means I just have 1 left. Now, I took out everything in this last term, this 3CD. That does not mean that this closes at the end here. I have to be able to re-multiply to get this last term to exist. So the minus sign still has to be here. And if I want to multiply something by another, I want to multiply by something and get the same result, what holds its place? A 1, right? So I need that 1 there to hold the spot, because when I distribute and re-multiply, I need to be able to get back where I started, okay? All right. These are practice. Let's do one of them. Let's do the harder one, and then you can see, you can try the other one on your own. You can always ask questions in chat, because you know now that you can do that if you have a question about either of these two. Let's do this second one. So I have a 16, a 12, and a 4. The greatest common factor there is a 4. I have a squared, a cubed, and a cubed, so the greatest is going to be a squared. I have b to the 5th, b to the 3rd, and b squared, so the greatest there is b squared. All right. 16 divided by 4 leaves me 4. I took out a squared, so I don't need to put an a here after the 4. I removed that. And then I took out b squared, so I have 3 b's left. Plus, let's see, 12 divided by 4 is 3. I took out a squared, I have a cubed, so I have just 1 a left, and I have 1 b left. They're the same. Plus, 4 divided by 4 is just a 1, so I can hold that spot. If you want to write it there, you can. A squared, I took out a squared, I have a cubed, so I have at least an a left. And I took out all the b's, so I'm going to leave that there. So that's what's left there. All right. You don't need that 1 as a placeholder here if you don't want it, but it can be there if you need it. If it helps you sort of remember where you're at, that's not a bad thing. All right. So in this case, I want to factor out a negative. It tells me to factor out negative 5a squared b from this polynomial here. So I'm going to take out a negative. When I take out a negative, what it's going to do is flip everybody's sign that's left inside the parentheses. So I know what I'm factoring out, negative 5a squared b. What I have to think about is what's left. So for the first term, I took out negative 5, okay? I took out a squared, so I'm left with a squared, because I had 4 of them, and I took out the b. So all I have left is a squared. For the second term, I took out negative 5. So negative 5 times what gets me negative 10? Well, negative 5 times positive 2 gets me negative 10, so I need that to be a plus 2. I took out a squared, I had a cubed, so I have just a left. And I took out b, and I have b squared, so I just have b left. Now in this last term, I took out negative 5, but I have a positive 15 right now. So if I took a negative 5 out of a positive 15, and I need to get a positive 15 back, negative 5 times negative 3 would get me positive 15. So I'm going to use a negative 3 here, okay? It's just flipping all the signs. It's positive now, it's negative now. I took out a squared, so I don't need any more a's. I took out b, so there's b squared left, okay? And the thing about having video notes like this is if you need to watch them again, you should go do that. Okay, so at some point, if you need to pause and rewatch what just happened, do that. That's okay. It's perfectly fine. In this case, we're going to take out negative 6xy. Negative 6xy. So let's see. If I take a negative 6 out of a positive 24, it's going to flip the sign of what's left. So it's going to be a negative 4. I have 3 x's left, and I have 2 y's. Now the 12 is already negative, so its sign is going to flip, and I'm going to divide by 2. That means I'm going to get a positive 2. I took out 1 x, so I have an x left, and I took out a y, so that just leaves me there. 18 is positive, so it needs to turn to a negative, and 18 divided by 6 is 3. I took out the x I had, and I have 1 y left. Okay? All right, next thing. The second part of what's in here is factoring out a binomial factor. This looks much scarier than it actually is, right? Here's the thing. When you're factoring out a common term, you're really just looking for what's common. So let your eyes look here. What's common? This, right? This x plus 2. This is a thing. Okay? If they're all the same, you can just pull them to the front. X plus 2 stands for something. This is a quantity in and of itself. I have it repeated. And if it looked like this, if it was 4x cubed plus 4x plus 4y, the common thing would be 4, right? Everybody's got one. It's not any different here. All right, so I'm going to pull x plus 2 to the front. That's the greatest common factor. Then I'll multiply by what's left. X cubed, keep the signs, minus x, minus 9. That's it. Done. Happy days. I'm going to try it again. All right, look at this one. What's the greatest common factor? What do you see? I see b plus 2, right? Okay, so I'm going to pull b plus 2 to the front. And then I'm going to put in parentheses what's left. A squared plus 5. Done. All right, it's not always that simple though, of course, because that would just be too nice to us. So when we factor out by grouping, what we do is identify and factor out the greatest common factor everywhere. That's always the first step in factoring. If there's a greatest common factor, we take it out. Then we factor out a greatest common factor from the first pair. We make groups. That's hence factoring by grouping. We factor out the greatest common factor from the second pair. Sometimes we have to factor out the opposite, the negative. It's just to make it work out right, you'll see. If there's a common binomial that's created and that's the goal, factor it out. This sounds crazier than it really is. All right, so we're going to make 2 groups. First, I'm going to look and go, okay, is there a greatest common factor? Well, no, not at all. Not everybody has anything in common. That's fine. So now I'm going to make 2 groups. I'm going to do a blue group and a green group. Okay? And I'm going to treat them separately. I'm going to look at the blue group first. So I have a 6 and a 21. The greatest common factor there is 3. And I have an A and a B in the first one and just A on the second one, so an A. Okay, so I can take out a 3A. So what's left here? 2B minus 7. Okay. Now I'm going to look at the second term. I'm going to have a plus there because that's what's there now. And I'm going to look. I have a 4 and a 14. What can I take out of there? I can take out a 2, right? And only one of them has a B, so I can't take that out. But let's see what's left. 2B minus 7. That's handy because now what I see is these terms match. That's the goal of factoring by grouping. Okay, so I'm going to pull that to the front, 2B minus 7, and then gather up what's left, 3A plus 2. Look, we factored by grouping. Ta-da! Okay, let's try it again. You take a second and try it. I don't know if you will or won't, but you should. Okay, first look for a common term. Do you see anything? No? Okay, I don't either. And then let's make groups. Green group, blue group. What can we take out of the first group? What's in common? Just a C, really, right? So I get 7C plus D left. Okay, and in the second group, what's in common? Just a 2. So take out a 2, and I get left 7C plus d. All right, and now I have a common binomial. There it is. So move it to the front. 7c plus d. And then gather up what's left, c plus 2. All right. Okay, a couple more of these. Let's try this one by grouping. Okay, this one's going to work a little differently because there's a negative in here. That's weird. So let's make this work. Let's make our groups. First, do I see any common factor? No, because not everybody has something. But here's one group, and here's the other. Okay, so I'm going to take out, let's see, I can take out x squared from the first set. Oops, I should have done that in blue. I'm making my colors wrong. X squared, so that leaves me with x plus 3. Now the thing is, the whole idea is that I want this binomial and this binomial to match. The only way I can do that is to pull a negative factor out of here because I want this sign to become a plus. So instead of just factoring out 3, I'm going to factor out negative 3. So I'm going to take out negative 3. That's going to leave me with an x. I'm going to flip that second sign, plus 3. And now my binomials match. Now that they match, I can pull them to the front. There they are, and gather up what's left. Okay? Okay, you try this one. 2 groups. Same idea. Out of the first set, I can take a squared. That leaves me with a minus 4. And now I have to think about that for my second set. For my second set, I want a minus sign here. So I'm going to pull out a negative 3, a minus 4. And then I'm going to gather up what I have, or move my binomial first, a minus 4, because they match. Gather up the rest, a squared minus 3. There we go. This one is ugly looking, but it's not as bad as you think it is. Just take it one thing at a time. Do you see a common term? If you do, pull it out. Okay, so I see that everybody here is divisible by, well, not really anything. Well, actually, everybody's divisible by 3, right? Yep. And they at least have one P and one Q. So I'm going to take out the common term that everybody has first, because the more I can do that, the easier my life will be. So I'm going to take out 3 P Q and rewrite what's left. That gives me, let's see, 8 PQ minus 6 P, just no Q left, plus 20 Q minus 15. All right. Now we can factor by grouping. I can't leave this middle gunk like this. That's not okay. But I can reorganize. So I can make a group here, and I can make a group here. Okay, so I'm going to leave this 3PQ at front. It doesn't disappear just because you're not using it. It's important because it'll help me re-multiply back to my original if I need to do that. So now look at the red group. I can pull out, let's see, a 2 and a P. That gives me 4Q minus 3. Hopefully this will work. Plus, I can pull out, let's see, out of, oops, colors, 20 and 15, I can pull out a 5. So pull out a 5, gets me 4Q minus 3. Ta-da! All right, so this is my common term now, right? 3PQ here. Pull out the 4Q minus 3. Gather up what's left, 2P plus 5. Done. Okay, let's try one more. Then we're almost to the end. Okay, grab your common term first. What do you see? I see 2x. They're all even and they all have an x. So pull out the 2x. What's left? See, 12xy minus 6x plus 10y minus 5. Okay? Now go through the process of factoring by grouping. Here's a group. Here's a group. And it's okay to draw the things that I'm drawing. Okay? It's fine. I draw them to help you, but I also draw them if I'm doing this by myself. It helps me see what I'm doing. So in the first group, I can take out 6x. So that leaves me with 2y. And remember, I need to hold this spot right here. So minus 1, right? I can't just disappear it because then I can't get back to where I started. And let's look at the second one. I need to pull out 10y minus 5. I can pull out a 5. And then I've got 2y, same thing happens, minus 1, which is a good thing. So here's my common binomial right here. So I'm going to keep my 2x minus 2y minus 1, or sorry, times 2y minus 1, gather up the rest, 6x plus 5. Okay, cool. One last idea. We're going to factor by grouping, but here's the thing. Sometimes you look at this and you go like, oh, well, those don't really have much in common, and these could be better. It is totally okay to rearrange your terms, okay, and put them in a different order. Just remember the sign belongs to the guy behind it, okay? So maybe I want to rearrange this to be 4x minus 3px plus 6pa minus 8a. Maybe you rearrange it different. That's fine too. Just remember the signs have to go with what they belonged to. And then once you do that, you can go back to grouping. Sometimes the grouping you have just isn't effective, right? You look at it and you go like, I could do better. That's fine. So out of this first group, I'm going to pull an x. So I get 4 minus 3p. All right. Out of the second group, let's see what happens. Is it going to work the way I want? Not really. I want to switch those guys around. See, this even happens to me. So I would like to do minus 8x plus 6pa, and I'll show you in a second why. So then I have, because I want to get this as my binomial. But if I do like this, what am I going to get? I'm going to pull out a 2 and an a, and my things are going to be backwards, and that's not helpful. So I can still pull out the same common term. I'm going to pull out a negative 2, though. Oh, this should be an a. Sorry, I made x's. Minus 2a. So that leaves me with 4. Remember, I pulled out a negative, so this becomes a minus 3p. Okay? So now my binomial is 4 minus 3p, and I'm left with x minus 2a. Okay? Sometimes it takes a couple of tries to rearrange right. It's not a bad thing. It just happens. Okay, so try this one. How do you want to rearrange it? Maybe, let's see, you want it so both groups have something in common. So I'm going to put 2s, oh boy, and sy together, plus sy, and then 3ry and 6r together. So here's my two groups. Let's see what happens. Maybe it'll work, maybe it won't. So out of the first group, I can take an s. Leaves me with 2 plus y. Out of the second group, I can take 3r, and that leaves me the y plus 2. Now here's the thing. Y plus 2 and 2 plus y are the same thing. It only matters if you're subtracting. But technically, I should switch these two around. Okay? That would get me 2 plus y. My binomials, I'll make that prettier, 2 plus y. My binomials will match, and then everybody's happy. So I can make 2 plus y at the front, gather up the rest, S plus 3R. All right, so this is the end of your first section of notes for this week. Hooray, you did it. Move on from here to the next things. And if you need to rewatch any of this, please do, okay? All right, let's see you at the next one.